Hello guys, so here we will going to see the answer of one question that is given on the screen. Okay, so I have taken this question from the previous year board examination question paper of the 2019 of the mathematics standard of 10 class. So you can see this question belongs to the trigonometry chapter, where we have to solve lots of the question of the prove that means proving the trigonometric identities. So you can see this question is actually came in the board exam. So we should be very prepared for such questions, and we should know how to approach such questions in the exam. Sometimes what happen is that most of the time we see the variety of the question for proving the trigonometric identities. So there used to have a lot of a question, so we can't able to solve each and every question. But if we will going to solve some tricky questions, or if we know the approach for such questions, we can solve any type of a question after doing lot of the practice. I will help you to solve this question so that we will get the idea how we can solve easily. So you can see here the question is given on the screen. It is also given in the Hindi and the English also. I will explain it here very well. So you just look on the screen and understand the steps that I am following here. So it will be easier for you to solve the question on your own also. Okay. Whenever we see the questions like this, we have to take any two approach. Either we can take the LHS or the RHS side. Means the we have to choose the side which is complex one, and we have to simplify it into the simple side. Or another practice is that we can take the both side independently, and we will obtain some common answer in the both procedures, and we will going to equate them. So basically for such questions, most of the time the rationalization procedure is used, but sometimes it becomes very tricky that we can't able to get the thing that is given on the right hand side. So for that we have to take both the sides independently. So we will going to take that second approach to take the LHS first, then we will simplify it, and then we will take the RHS, and we will again simplify it, and we will get some common answer. Although the question is looks like a very trickier one or a complex one, but whenever we will see, or whenever we will going to see the solution, then you will going to know that it having a very less amount of the steps involved in its solution, and it is a very easier question. So you can get all the 4 or 3 marks whatever there used to be there in the question paper. So I'm not saying that perfectly this question will come again or not, but obviously such type of a question will be asked in the board exam, also for the CBSE board, also for the ICSE board, and also for the state boards exam. And also this is not only the question which is useful for the CBSE board only, but other students or other board students can also follow this question or follow this solution, so they will going to get the help from this solution. So okay, I have already taken the time. Now we will go for the solution, so you can see on the screen now. Okay, so here I will take the LHS. Okay, so what is given in the LHS? Sin A minus cos A plus 1 upon sin A plus cos A minus 1. Now for solving such question, there would not be only one trick. Okay, there may be having the lots of the tricks and lots of the concept, but I am using the concept that I will keep as it is whatever given in these terms. I will not going to change them into the sec theta or tan theta or something like that. Now what I will do, I will just do the rationalization. Okay, I will just do the rationalization for, but basically we know that we can do the rationalization of the two terms in the denominator or the numerator easily. But now you can see here there are the three terms. Okay, so what I will do, I will take this two as single term, these two as a single term. Okay, so I will write like sin A minus cos A plus 1 upon sin A plus cos A minus 1 multiplied by, I will rationalize the denominator here, so I will write here sin A plus cos A plus 1 sin A plus cos A plus 1. Okay, so what is here? Sin A minus cos A plus 1, sin A plus cos A plus 1. Okay, now you can see here sin A. In this numerator, sin A plus cos 1, here sin A plus cos 1 are the positive terms. So I will take them together. sin A plus 1 and minus cos A multiplied by sin A plus 1 plus cos A. It is sin A plus cos A, it is sin A plus cos A minus 1 and plus 1. So can we apply the identity that is A square minus B square? Okay. So I will write here sin A plus cos A whole square minus 1 square simply. Okay. Again on the numerator side, sin A plus 1, sin A plus 1 minus cos A plus cos A. So again here I can apply the same identity, that is A square minus B square. So what is my A here? Sin A plus 1 is my A and my B is cos A. Okay, so I have written it. Now sin square A plus cos square A, I will expand it. So it becomes sin square A plus cos square A plus 2 sin A cos A. What I have done, I have applied the identity that is A plus B whole square. Okay, and this is okay. For this I have written the 1. Now again I can expand this, so it will become sin square A plus 1, okay, A square plus B square plus 2AB, that is 2 sin A. Now what is B here? Only 1, so no need to multiply it by 1. Okay, sin A. What is remaining here? Cos square A. Okay. Sin square A, sin square A plus cos square A, what is that? 1. Okay, so it will become 1, and what is minus 1? So sin square A plus cos square A is 1 and minus 1, it will become 0. So I will write here only 2 cos A multiplied by sin A. Again here we know that sin square A is here and again plus 1, okay, and it is cos square A. Can I write sin square A plus 1? Okay, can I write this plus 1 as a sin square A plus cos square A? Yes, I can write it sin square A plus cos square A. That is the first fundamental identity, that is sin square A plus cos. So instead of this one, I have written these two terms, then plus 2 sin A minus cos square A divided by 2 cos A sin A. 2 cos A sin A. So now you can see here plus cos square A minus cos square A cancelled. Okay. Now sin square A plus sin square A, that is 2 sin square A plus 2 sin A divided by 2 cos A sin A. Now I will skip one step and I will go only, and now I will going to skip one step and I will directly tell you that 2 sin square A, 2 sin A upon 2 sin A cos A. Can you see there 2 sin A is a common term there? 2 sin A is a common term. So what is remaining here? Sin A plus 1 divided by 2 cos A multiplied by sin A. So can I cancel this? Because they will divide to each other. So what is remaining? 1 plus sin A upon cos A. Okay, again we can simplify it by writing sec A. That is, I will separate out the term 1 plus sin A upon cos A as 1 upon cos A plus sin A upon cos A, that is tan A. Okay, tan A. So I have got this simplified version of the LHS, that is sec A plus tan A. Now I will go back to the given question. So you can see here we have to prove this term, that is 1 upon sec A minus tan A. Okay, so that is given on the RHS side. So I will take it again separately. So I will write now RHS is equal to 1 upon sec A minus tan A, sec A minus tan A. Can I again, now it is written in the denominator that sec A minus tan A. I can rationalize it simply. Okay, I can rationalize it simply, or I can again write it. So I will rationalize this. So it will become 1 upon sec A minus tan A multiplied by sec A plus tan A tan A. Okay, so it will become sec A plus tan A. Now it is sec A minus tan A, sec A plus tan A means A square, A minus B, A plus B. So I will write here A square minus B square, that is sec square A minus tan square A. Now I know the second identity. What is that second identity? 1 plus tan square A equal to sec square A. So can I say sec square A minus tan square A is equal to 1? Okay, so it will become sec A plus tan A upon 1, that is equal to sec A plus tan A. Can I give it equation number 2? Yes, I can give it equation number 2. So here we come to know that from the equation number 1 and 2 that we are getting the same expression for the LHS and the RHS, that is sec A plus tan A, sec A plus tan A. So from that I can say LHS is equal to RHS. So hence proved. So in this way we can calculate or we can solve this question step by step. I hope that you got the steps that I have taken here, or whatever the steps which are involved in this solution. Okay, I think this question becomes very important regarding the exam, because in this question we have seen lot of the things, means we have used the two basic identities, sin square theta plus cos square theta equal to 1 and 1 plus tan square theta equal to sec square theta. Another is that we got to know how we can apply the rationalization procedure for the three terms also, and how we can obtain the solution. So I hope you got the solution of this question and you can solve some other questions like this on your own. Okay, so thank you so much.